The next point is here general form of a line. So it is given by this, as we were getting in the previous exercises, ax plus by plus c equals to 0. This is a linear equation in two variables. Sometimes you can use capital A, capital B and capital C also. So ax plus by plus c equals to 0, whichever you use, whether you use this or this, both are same. This is a linear equation in how many variables? Two variables. X and y are variables and a, b, c are constants here. This is a general form. Whenever you have a straight line, always we try to find it this form: ax plus by plus c equals to 0, where a, b, c all are constants. These are the constants, and x and y are variables. This is called linear equation in how many variables? Two variables. Okay, now three things I want to write from this linear equation. One is a slope, right? We know two ways to get the slope. The one way is what? Using angle theta, so that is given by tan theta. If you have 2 points, then you can get the slope by y2 minus y1 upon x2 minus x1. Fine. This is indirectly third way of getting the slope if you are given the equation of the line. In both the previous method, either you have angle or you have 2 points, right? This is slope, this is slope. But in this method, you have the equation of the line. Then slope is given by this minus a by b. It can be derived. We are not getting into that again. Right? Proof is there in the textbook. If you are interested, you can refer it. I am not getting into that. But this is the formula, minus a by b. What's the formula? Minus a by b. What is that a? It's a coefficient of x. Coefficient of x. And what is b? It is nothing but the coefficient of y. Coefficient of x and coefficient of y here. Minus sign is there. For example, if I asked you 2x plus 3y plus 1 equals to 0. Fine. Now this line you are given. You cannot get the slope by earlier two formulas because there you need the angle and 2 points. Here you are given the equation. So what is the slope? Minus a by b. So minus 2 by 3. You know that the slope is a number, which you know very well. Positive, negative, 0 and so on. If you are given this, for example, x minus y plus 2 equals to 0. What is the slope here? Minus a by b. A means coefficient of x, which is 1. B means coefficient of y, which is minus 1 here. Don't take 1. So finally slope will be 1 here. If you are given this equation, 2x plus 3 equals to 0. Have you realized which variable is absent here? Y. So it must be parallel to which axis? Y axis. And if you have any line parallel to y axis, that's a vertical line. Do you remember the slope of any vertical line? Like this. Undefined. Here also you'll get the slope equals to undefined. Look at this. Here a is 2. Variable y is not there means what? Coefficient of y is 0. So minus a by b. But b is 0 here, which is undefined. Something upon 0 is undefined or infinity. Got it? You can rewrite this equation. If you have still confusion, you can rewrite like this: 2x plus 0 into y plus 3 equals to 0. Got it? So a is 2, b is 0. And it is expected because it's a vertical line. Now you know by just observing the equation. One more, as you know, suppose if I write like line like this: y plus 11 equals to 0. Which variable is absent? X. So it must be parallel to which axis? X-axis. This is a line passing through minus 11. This is just rough diagram. So it's a horizontal line. So slope has to be 0 here. Okay. So write the slope here: minus a. A means coefficient of x, which is not present. So it is 0. Upon coefficient of y, which is 1. And 0 by 1 is always 0. So slope is 0. You can rewrite still if you want. You can write like this: 0 into x plus y plus 11 equals to 0. Fine? Clear concept of the slope? So now keep in your mind there are three ways to get the slope. 1 by theta, 1 by 2 points, and one more by what? Equation. How many ways are there to get the slope? One by angle theta, that is tan theta, where theta is the angle with the positive direction of the x-axis. The other one is by 2 points, that is this one. And third one is, if you are given the equation of the line, always you can get the slope by this formula, minus a by b. Minus a by b. What is a? That's a coefficient of x. What is b? That's a coefficient of y. And one more thing we want to write, that is x-intercept. If you are given the if you are given the equation. Now x-intercept, if you are finding, then y coordinate must be 0. You just go back to that theory, you will realize. So put y equals to 0 here and make the x as a subject of the expression. So it will be minus c by a. What I did nothing. You just go back to theory of x-intercept. Whenever you are finding x-intercept, y will be 0. Make the x as a subject of the expression. So minus c by a. You need to remember, if you are given the equation, x-intercept you can find by this formula, minus c by a. What is y-intercept? So same concept. For y-intercept, reverse you need to keep in your mind. Put x equals to 0. Make the y as a subject of the expression. So minus c by b. So three things you have from the line. Okay, slope, x-intercept and y-intercept. Suppose I have this line, 2x plus 3y plus 6 equals to 0. Let's take this. Okay, what's the slope? Now tell me fast. Slope m is minus a by b. So 2 by 3. What is x-intercept? What is x-intercept here? X-intercept is minus c by a, which is 2, which is minus 3. Or you can just put y equals to 0. Make the x as a subject of the expression. What is y-intercept? Put x equals to 0 if you do not remember that formula. Formula is this, minus c by b. What is b? That is 3. So minus 2. Or put x equals to 0. Make the y as a subject of the expression. You'll get this. So line passes through which point indirectly? Have you noticed? So line would look like this. X-intercept is minus 3. That means it will pass through minus 3, 0. And y-intercept is minus 2. That means here 0, minus 2. So your line would be like this. This is the line. Right? Clear? Understood? This is the line that passes through minus 3, 0 and 0, minus 2. That's what the precise meaning of intercept. Okay. So I think these two things are clear to you. X-intercept and y-intercept. Now we have two more theories here. The next one, that is, we find a distance of a point from the line. This is the second last theory of this chapter. We'll use later on also. So distance of a point from a line. So you are given a line and point and you are finding the distance. Right? When we say that we are finding the distance, it is understood we are finding perpendicular distance. Distance in the sense of perpendicular distance. Okay, the distance of a point from the line. Okay, so I'll write the equation of the line. Now always we use the general form, ax plus by plus c equals to 0. This is the equation of the line. Which equation? Ax plus by plus c equals to 0. This is line. And you have a point here. I'll take that point as x1, y1. Point is not on the line. x1, y1. Let me call this as point P. Okay, so here it's like this. Suppose we have a line like this here. This is a line. It's a equation you are given here. Let me call the line L here. There is a point P here which is not on the line, outside the line. This is point P. Then we want to get this perpendicular distance. It's understood when we use the word distance means perpendicular. I'll call this as M here. So we want this PM. Perpendicular distance of a point from the line. We want this PM. This is a question. Now you can just refer the textbook if you are interested in proof. I'll not write the detailed proof. I'll just state the formula. Okay. So I'll write here the perpendicular distance. It is understood when we write just distance, that means perpendicular distance equals to PM. You can use the small p also. That's this distance, small p. This one PM. It is given by this. We take the modulus. In case inner expression is negative, we make it positive. Okay, now formula is very simple, again not difficult to remember. In this equation, just in place of x you write x1, in place of y you write y1. So ax1 plus by1 plus c. What I did, I repeat. Instead of x you write x1, in place of y you write y1. So x1 plus by1 plus c. Upon inside the square root, square of a squared, square of b, which is b squared. This is the formula. Perpendicular distance of a point from the line. Modulus of, why we are putting modulus? In case if this number is negative, we make it positive. Modulus of ax1 plus by1 plus c upon under root a square plus b square. No, you need to remember, we'll use frequently even in 12th standard also. Like this, I'll just do a simple example. Suppose line is this 2x plus, let me write 3y, or let's write 4x plus 3y plus 2 equals to 0. And point I'll take randomly, let's take 1 comma 2. Okay, so you have a line here and you have point here. So we are finding this PM. So we have prepared formula here. So I'll write perpendicular distance equals to, you can write small p or PM, modulus of ax1 4 into 1 plus 3 into 2 plus 2 upon root of, right, do not write 1 square plus 2 square, coefficient of x, so 16 a square, and this is 9. So how much if I simplify this? This will be just 5. What about this? 4 plus 6 10 plus 2, so 12 by 5, whatever it is, but that's the required distance. Fine. Next theory here is distance between two parallel lines. Which lines? Here we want the distance between two parallel lines, not any lines. So we take two lines which are parallel here. Just in a diagram, if I show it, one line is like this, the other line is like this. These are the two parallel lines here. Okay, we want the distance between these two. Now it is again understood when we say distance, it's a perpendicular distance like this. We want this perpendicular distance between these two here. We want this. Okay, so we write the equations first of two parallel lines. In general, we write ax plus by plus c equals to 0. Whenever we recall right, immediately we must have this equation. What's the slope of this line? Minus a by b. Now they are parallel, so I need to take this much same. I need which lines? Not any two lines, parallel lines. Suppose L1 and L2. Got it? I need parallel lines. See. What's the slope of this? Minus a by b. So I need to take ax plus by. I cannot take something c plus d. But if I take the same, then both will be identical. So just to distinguish these two, I'll put the c dash. You can notice that the slopes of these two lines are equal. What's the slope of this? Minus a by b. What's the slope of this one? Minus a by b. That means these two lines are parallel by equations. Fine. Now we want this perpendicular distance here. We want this perpendicular distance. So again, I'll state it directly. You can just refer if you want the proof. Perpendicular distance, you can call again small p here also, this much, which is given by this formula. Very simple formula. Difference of these two constants, c minus c dash upon under root this coefficients, that is a square plus b square, as you had in the previous formula. This is the perpendicular distance between two parallel lines. What's the formula here? Root of, when the modulus c minus c dash upon root of a square plus b square. What is one important thing you should notice from this beginning, that their coefficient should be same. Ax, by, see. Then you have this. If these are different, you cannot use this formula. Like this. See, if I have one equation like this, 2x plus 3y plus 1 equals to 0. The other one I'll write 4x plus 6y plus, let me write here, plus 3 equals to 0. You can see that these two lines are parallel. That much you can notice now. What's the slope of this? Minus 2 by 3. What's the slope of this? Minus 4 by 6, which is again minus 2 by 3. Slopes are equal, they are parallel. But coefficients are different. You see here 2, here 4. Here 3, here 6. So here, as per this theory, you need to make the coefficients equal. Otherwise, how do you choose A and B? You can take 2, 3 or 4, 6. That question arises. So there are two ways. One way is either you can divide by 2 or you can multiply this by 2. Choice is yours. I'm multiplying throughout the equation by 2. Slope remains same, remember. Just I'm multiplying with 2. You can verify. Again, slopes are equal and they are parallel. This I'll keep as it is. I did nothing with this. Now, instead of this, I'll use this and I'll use the formula. So, perpendicular distance equals to small p equals to, what's the formula? C minus C dash. So, 3 minus 2 upon root of a square plus b square. So, either you can 4, 6 or this. Now, they are equal. Got it? You cannot use this 2. Otherwise, immediately there will be a question whether 2, 3 should be taken as AB or 4, 6. So what I did, I've just multiplied this by 2. Or else, you can keep this one as it is and you can divide this by 2. Choice is yours. Okay, so 16 here plus 36. So this is 1 upon, you have root of here. So now with this we go to next exercise 10.3. The first question. Reduce the following equations into slope-intercept form. Slope-intercept form. Do you recall which one is the slope-intercept form? Y equals to mx plus c. We have discussed. This is one of the standard form. And find their slopes and y-intercepts. You need to write in this. In this P means what? Make the y as a subject of the expression. So first one, x plus 7y equals to 0. Make the y as a subject of the expression. So minus 1 upon 7 into x. Compare with this. What's the coefficient of x here? Minus 1 by 7. And plus you can imagine 0 here. So c is 0. Slope is minus 1 by 7 and what is here that y-intercept? It's 0, right? Find the slopes and y-intercept. Okay, second question. What about the second here? Second one is 6x plus 3y minus y equals to 0. So make the y as a subject of the expression. So minus 6x plus 5. Every time this form, you are asked special in this form. This form means make the y as a subject of the expression, then coefficient of x is slope and that constant is y-intercept. You know, we already discussed this form. This form we already discussed earlier. Okay, so y will be dividing by 3. So minus 2x plus 5 by 3. Coefficient of x is slope, minus 2. And c is 5 by 3. Here c is not any constant. It is, what is c here? That is y-intercept. Okay. Now here, let me clarify one more thing. Do not get confused with here c used in this form and c used in this form. Okay. Here c is any constant and here c is y-intercept. Okay. So do not club these two things. There C is any constant. In this form, ax plus by plus c equals to 0. C is any constant. Here C is y-intercept. Fine. Third sub question. Let me do it for you. Y equals to 0. It is already in y equals to mx plus c form. You can write like this. Y equals to here. You can write here 0 into x plus 0. So what is the slope? That is 0. Slope is 0. And what is c? That is also 0. Do you know what is this? This is x-axis. So slope has to be 0. And where it intersects the y-axis at origin. So this must be 0. Okay. Question number 2. Second question. These are all basic elementary questions. If you understood theory, you can answer all these questions very easily. Okay. Next question. Reduce the following equations into intercept form. Okay. Intercept form means which form? So x upon a plus y upon b equals to 1. You want this form. Okay. So what we'll do? We take constant on the right hand side and we make it 1. Like see, first question. Which question? 3x plus 2y minus 12 equals to 0. I'll take constant on the right hand side. 2y equals to 12. I need 1 here. So dividing by 12. So this will be x by 4. Y by 6 equals to 1. What I did? Dividing by 12. I need just 1 on the right hand side. So what are the intercepts? Intercepts are 4 and 6. This is with x and this is with y. What's the meaning of this? That means this line intersects the x-axis at 4, 0 here and y-axis at which place? 0, 6. So your line will be like this. Clear? You know it now very well. Okay. What about, let me go to third sub question. Second you can do very easily. Third sub question is 3y plus 2 equals to 0. Okay. So we'll write 3y. I'll take constant on the other side minus 2. I'll make it 1. So 3 by here minus 2 and that coefficient I'll take down equals to 1. Got it? What I did? Is this clear to you? What I did? I've tried to express in which form? I've tried to express in this form. Which form? X upon a plus y upon b equals to 1 form. Got it? Now here you know that that's quite obvious that that this is not present here. So only y-intercept upon b represent y-intercept, you know. So what is y-intercept here? That is minus 2 by 3. Intercept of the line with y-axis. And what about x-intercept? X-intercept is undefined. It's not there. Doesn't exist here or not defined. Does not exist or not defined, whichever you write. Not defined. Have you realized why that x-intercept is not defined? Because your x variable is absent. So line must be parallel to x-axis. So it will never intersect the x-axis. Did you notice here? X variable is absent. So line must be parallel to x-axis. So it will never cross the x-axis. And that's why x-intercept is not defined. That you know now very well. And it should be very clear to you. Okay, question number 3. That's most important question of this exercise. See. What you want to do? Please read the question. Reduce the following equation into normal form. What's the normal form? Can you recall from that standard form? P alpha form, if you remember. X cos alpha plus y sin alpha equals to P, where P should be greater than 0. You know, this is known as which form? Normal form. So we want to reduce in this form. Okay. Find the perpendicular distances from the origin. If you remember, as per theory, that is P. Then we find these two things. Then we find, after expressing P, that is a constant on the right hand side, and angle with the positive direction of the x-axis, that is that alpha. These two things we want to do. Earlier, if you remember, if you were given two things, you were finding the equation. We had such question. If you are given alpha and p, you can get the equation. Now we want to do reverse. If you are given the equation, we want the p and alpha. So what we'll do here, Listen, the first question is x minus root 3y plus 8 equals to 0. First I'll take constant on the right hand side, but it should be positive. So in short, I'll take these two terms on the other side. So minus plus root 3y equals to 8. Have you realized what I did? Constant should be positive. Right hand side expression term should be positive. So I took these two expressions on the other side. Now, secondly here, in the standard form, if you look at, see, here, what is the coefficient of x cos alpha? What's the coefficient of y sin alpha? Do you remember what is cos squared alpha plus sin squared alpha? It has to be 1, right? What's the coefficient of x here? Minus 1. Square it, 1. What's the coefficient of y here? Root 3. Square it, it will be what? Here, square it. How much it is? 3. So it is 4 here. So, here, the sum of the squares of the coefficient should be how much? 1. Here you are getting 4. Right? After squaring, it should be 1. So, to make it 1, what I'll do? I'll divide by 2 throughout this expression. Why 2? Here you are getting 4, but that is after squaring. So, I should take the square root of this. Got it? Have you realized? In short, you are dividing by a squared plus b squared. What is a? Coefficient of x. What is b? That's a coefficient of y. You are dividing by this. If you just want the general thing, dividing by this. But it should be very clear in your mind why you are dividing by this. Got it? Okay, so this looks like what? Cos alpha. What is cos alpha? Minus 1 by 2. This looks like what? Sin alpha. Now you can verify that cos square alpha plus sin square alpha is 1. 1 by 4, 3 by 4. So it's 1. Got it? Earlier it was not. And what is right hand side? That is now that constant p. So what is p? P is nothing but 4. So perpendicular distance from the origin is 4. And how do you get the alpha from this? Alpha from this? You see cos negative, sin positive. Cos negative, sin positive. So it will be which quadrant? Second quadrant. So your pi minus, for what value of alpha? Cos alpha becomes 1 by 2 and sin alpha becomes root 3 by 2. You know it is pi by 3. So simplify this. So it will be 2 pi by 3, right? This is your alpha. This must be clear too. Why I wrote pi minus pi by 3. Okay, let's do one more here. Y minus 2 equals to 0 here. So first we take the constant on the right hand side, which is 2. It should be positive. Now this you can write like this. X is not present. 0 into x plus y equals to 1. Now what you need to check? The coefficient of x squared plus coefficient of y squared should be 1, and it is here 1. So it is already in this form. Which form? X cos alpha plus y sin alpha equals to now in p form. No need to divide by anything. Clear? What is cos alpha here? Cos alpha is 0. Coefficient of x. What is sin alpha? It is here 1. Okay, so what should be your alpha from this? For what value of alpha? Cos alpha is 0 and sin alpha equals to 1. Obviously pi by 2, or you can write 90 degree. Fine. And what is your p? That is a constant on the right hand side. So p will be 2. So that's your required values. Third question, let me see. I'll not do it. Try yourselves. Third one, x minus y equals to 4. Try. Not difficult. But this is important question, as I told you earlier. Question number 4. Find the distance of the point from this line. Okay. So as I explained in the theory, point is minus 1 comma 1. So this is x1 y1 as per our notation. Line is given by this 12 into x plus 6 plus 5 into y minus 2. It is not in that general form. We should write it. So here 12x plus here 72, here 5y minus 10. Got it? So what we'll get from this? 12x. This one I'll take on the left hand side. So minus 5y. And here plus 82 equals to 0. Got it? Now I've expressed in which form? I've expressed in which form? Now you can see that ax plus by plus c equals to 0 form. Right? This is not in that form. Ax plus by plus c equals to 0 form. Okay, so we'll write the perpendicular distance equals to small p equals to modulus 12 into x1, which is minus 1. Here minus y minus 5y, but what is y? That's 1, plus 82 upon root of a square plus b square, that's 144, plus how much? 25. Why have you realized why I have expressed this line in that form? To get a and b. Ax plus by plus c equals to 0. I need a and b. From this directly you cannot get a and b. That's why I did in that form. Now this is minus 12. This is minus 5. This is how much? 82. Right? Upon this is 169, which is 13. So from this this is minus 17, so I'll get the here 65 by 13. Modulus is there, so you have 5 units. If you want, just you can write the perpendicular distance equals to 5 units. In the next question, you are given a line and its distance from the x-axis is 4 unit, and the question is find the points on the x-axis. Let point be this. You can write point on the x-axis as a comma 0 on x-axis. On x-axis y coordinate is always 0. So this is like x1 y1 as per our theory, and we want both the coordinates, that is specially a. Okay, now as the distance equals to 4 you are given. Okay, so therefore 4 equals to, we'll use the formula ax1 plus by1 plus c upon under root a square plus b square. You want x1, that is a. So 4 equals to, line is this. It is in this form. I've just taken LCM. I've expressed in ax plus by plus c form. So 4 into x1, which is a, plus you have 3 into y1, that is 0, minus 12 here, upon root of a square plus b square, which is 16 plus 9. Just in this line, instead of x you wrote a, instead of y you wrote 0. This is nothing but here 25, so 5. So this is 20, and 4a minus 12. Drop the modulus. So 4a minus 12 equals to either 20 or 4a minus 12 equals to minus 20. So 4a equals to how much? Here 20 plus 12, which will be here 32. So a equals to 8. One possibility is what? A equals to 8. And similarly, if you simplify there, the other possibility here, 4a equals to how much? Minus 8. So a is minus 2. You don't want here a, you want the point. So therefore 8 comma 0 you are placing here. Or the other possibility for the point is minus 2 comma 0. Right? This is also a good question. Same way, if you are asked for example, y-axis here, then the same way you can do the point as what? You can select the point as what? 0 comma b. On the y-axis, x coordinate is 0. If you are asked for y-axis, and you can do like this. I've used simply the formula. Okay. Next question. 6th question. Find the distance between parallel lines. Okay, so we did it one example when I discussed the theory. I'll do 6th second. There the lines are this. Slopes must be same and coefficients of x and y should be same. This is one line and this is the other line. Lx plus ly minus r equals to 0. Clearly these two lines are parallel, you can see. Why these two lines are parallel? Because you can see the slopes are equal. Minus 1 minus 1 minus a by b. Okay. So therefore here perpendicular distance equals to small p equals to modulus of c minus c dash upon under root a square plus b square. C minus c dash upon under root a square plus b square. So here C, you can take this or this, that's not important. So here P, this minus and this minus plus R upon root of a square plus b square, L square plus L square. So you can take L outside, so it will be 1 by L, your modulus of P plus R, 1 plus 1, it will be just 2, so you can have root 2. Modulus of P plus R upon, here also modulus, because that might be negative also. So in turn you can write like this, 1 by root 2 outside, modulus of P plus R upon L. If you want, you can just write units here. Okay, perpendicular distance between two parallel lines. Okay, seventh question. Such questions you can do now. What it says, find the equation of the line parallel to this. Okay, so you are given a line here, 3x minus 4y plus 2 equals to 0. Okay, you can get the slope of this very easily. What is the slope? Minus a by b. So what's the slope? 3 by 4. Slope of the given line. So what's the slope of required line? Slope of required line, tell me. Slope of required line, same, 3 by 4. Which concept? m1 equals to m2. Two lines are parallel if their slopes are equal, and therefore that by that concept these are equal. Just only new thing is way of finding the slope, minus a by b. Now you have a slope and point is already given to you. Line passes through which point here? Minus 2 comma 3. So you have point x0 y0, you have a slope, and therefore the equation will be that you can do now. Equation is y minus y0 equals to slope into x minus x0. Just use this, you can get the equation. Let's go to one more question here. Question number 8. What it says, 8th question, please read it. The 8th question says, find the equation of line perpendicular to this. So when you have the word perpendicular, immediately you must have m1 into m2 equals to minus 1 in your mind. Line is x minus 7y plus y equals to 0. What's the slope of this line? Minus a by b. So 1 upon minus 7, which is 1 by 7. Which concept you have used? Minus a by b. Slope of the given line. A is 1, b is minus 7. So slope of required line. Okay, now this is known to you how to. The only new thing is this point, how to get the slope. We are using third way to get the slope. So slope of required line equals to reciprocal with opposite sign. So it will be minus 7. Which concept here you have used? m1 into m2 equals to minus 1. Product of the slopes equals to minus 1. And x-intercept is here. X-intercept is 3. What's the meaning of this indirectly? Which point you are given? X-intercept is 3 means line intersect at 3 comma 0. So you have a point. X-intercept is 3 here. It implies the point is 3 comma 0. You have a point which is x0 y0. You have a slope which is minus 7. So you can get the equation of this line very easily. Right? How do we get it? Use the equation. So equation is y minus y0 equals to slope into x minus x0. What is y0 here? 0. What is the slope? Minus 7. X minus x0. What is x0 here? 3. So what we'll get from this? Y, this is plus 7x. This is plus 21. And if I take on the left hand side, minus 21. This is required equation here.